Welcome everyone. As you all know, clinical data often have limited usefulness because of the diversified expression. But manual coding cannot handle the hard Chinese clinical data at present. How can we turn the low-effective manual coding into the computer-aided toys? Today I'm going to talk to you about how we develop a automatic data cleaning and coding tool for Chinese clinical data standardization. My presentation is divided into four main sections. First, I'm going to introduce the background. As I said at the beginning, standardizing clinical data with controlled vocabulary can improve the quality of clinical data and promote the use of clinical data, including data retrieval, data analysis, data communication, data reuse, and data statistics. Standardization of Chinese clinical data is a complex and time-consuming process, usually performed by trained coders. First, the coders remove all duplicate data to reduce the workload. Second, the coders select keywords from the clinical data based on experience. Then search and confirm matching results from the standard. The amount of clinical data is growing rapidly in China, while the number of coders remains the same. It promotes the search for tools that assist manual standardization. Secondly, I'm going to introduce the methods. The architecture of the standardization process is shown in the figure. The Chinese clinical data are cleaned by pre-processing the text. Then a appropriate text similarity algorithm is selected to recommend the standardized results. The standardized Chinese clinical data are output after the manual review of the recommendation. The first part of the method is data processing, including file models, text segmentation, data duplication, error text deletion, irregular text replacement, and symbol processing rules. Text segmentation splits the text through rulers and adjusts error results manually with higher efficiency. So we can divide a clinical test. Designers neck muscle tension, meningioma into three parts. Designers neck muscle tension, and meningioma. Data duplication was processed by exact matching. 3 infection of respiratory tract was turned into 1. Error text has some meaningless special symbols and description, such as conservative treatment with medicine, B limit. Irregular text replacement needs return manual by coders in home encoding. Some description recognized to incorrect or changed through rule 6. For example, Otis MedR can convert into a standardized right Otis Med through the rule 6. The symbol processing rules was developed to fast handle different symbols. Some examples of symbol process were shown. The second part of the method is the text similarity algorithm. The standardization of Chinese clinical data with the text similarity was shown. There are 5 text similarity used in the tool. The added distance refers to the minimum number of insertion, deletion, and substitution required to transform one string into the other. The J card refers to the insertion divided the union of two texts. Cosine tax similarity measures the cosine of the angle between two word vectors. Chinese phonetic similarity identify words with similar pronunciation. For example, the pronunciation of Totong and the pronunciation of Toteng has a strong Chinese phonetic similarity. 同义词词林 is a Chinese concept dictionary that is similar but small to word night. 同义词词林 similarity use the coding structure characteristic of 同义词词林 to calculate the distance between two texts. The third part of the method is the manual review. It is difficult for the automatic coding algorithm to achieve 100% accuracy. The tool should have the manual review. Thirdly, I'm going to show some results. The same automatic tool have 5 text similarity algorithms, 2 standard clinical texts in different clinical domains. 5 similarity algorithms were used in diagnosis drug examination. It was found that the Chinese phonetic similarity algorithm was suitable for diagnosis and drug domains, and the ideal distance performed well in the examination domain. It is possible that the J-card and cosine similarity and 同义词词林 will achieve better results in some other clinical domains. The time of manual coding and same automatic tools that handle 100 diagnose date, 100 drug date, and 100 examination date were compared. The same automatic tool have no way to replace manual standardization, but it can greatly improve efficiency and reduce the time for manual work. Finally, I'm going to discuss the advantages and shortcomings of our study. I want to highlight the following advantage of our study. First, the hospital did in Beijing for research to make the toy that can be directly applied to practical work. The toy completed more than 30,000 standardization of Chinese clinical diet in 2 months, which showed high precision and efficiency. Second, the accuracy of the toy can be improved by building a high-quality synonym dictionary in the standardization process. Third, the existing manual coding was improved to reduce workload and improve efficiency by our toy. There are also some shortcomings in our study. First, only same automatic can be achieved and require manual review. Second, it is hard to determine the appropriate text similarity algorithm in different clinical domains or even different data in some clinical domain. That brings me to the end of my presentation. Thank you for listening.